So complex fractions are simply fractions within fractions. That's all they are. You've seen these on SAT tests all the time. You have a numerator with multiple fractions inside of it. So let's take a look at this right away. There are two methods we can use. There are two methods. I, personally, when I was a student, only did method 1. I never knew of method 2. I never realized that you can use an LCD for this. But method 2 is very useful. I'm going to teach method 1 first, and then I'll show you method 2 as well. And I'll let you choose which way you want to approach this. But for all of these problems in the notes, I've solved them with both methods, so you can see the notes later. If we don't get through every problem, you can see that they can all be solved with either of these two methods. Okay, so I'm going to start with the first method, with the first example. So the first method that we're looking at here is to find a common denominator of the major numerator. What do I mean by the major numerator? Why do I specify the major numerator? Why don't I just use the word numerator here? What's the major numerator instead?
This is like a guess. But would it be x since it's like all the way at the top?
So x could be one of my numerators. So could x, and so could 7, right? Those are all numerators. But if I just say if I say find a common denominator of the numerator, that doesn't make much sense. So major numerator, look at the major fraction involved here. Take a second stab. Think of the major fraction. Look, that's the major fraction, isn't it? So what's the big numerator of this whole thing? So that's like my numerator really, right? See what I'm saying?
Yeah.
And then this is like my denominator here, okay? So what I want you to do is this for method number 1. Take what is circled in blue and find a common denominator for it. For what's in blue, what's the common denominator clearly? 6, not 18, right? Be honest. Anybody pick 18? No? Nobody did it? Okay, good. Most students see 6 and 3 and they go right to 18, thinking 18. But it's 6 clearly, right? So in blue, let's do it in blue first. I need to multiply this by 2 over 2. And that's it for the numerator. I don't have to do anything else. But now let's look at the major denominator. The major denominator. Seb, what's the common denominator of the major denominator? 10. And that means we're missing a 2 times 2 over here. A 2 over 2 over here. So that gives me a common denominator up top of 6. So my major numerator becomes x minus 2x all over 6. And then that's over 2x minus 7 all over 10. Again, check the work, make sure it makes sense. You guys are all smart enough that I don't have to show every step, I hope, right? I'm multiplying by 2 here. That's really 10. Common denominator of 10 of both carries down. Common denominator of 6 carries down. Then I can simplify, obviously. More okay. That's what you're going to say? Yeah. So let's simplify this guy. Negative x over 6 all over. And I'm going to use arrows here, by the way. I'm going to use arrows and not equal signs. No equations here, right? Now, at this point, you know enough about math that you should be able to figure out what to do next. When I divide two fractions, what should I do? You've done it. All your life, you've done it. Dividing two fractions is the same as?
The state change flip.
Yeah, state change flip. So multiply by the? Reciprocal. State change flip, yep. It's a good mnemonic device, that works. So let's take the reciprocal of the denominator and multiply by it instead. So this next line we're going to get, I'll carry down at the bottom here. We'll say the following. Negative x over 6 times 10 over 2x minus 7. Again, I'm dividing two fractions, so I take the first fraction, and instead of dividing by the second fraction, I multiply by the reciprocal of the second fraction, which is in this case the denominator. Any simplifications that can occur? I see a 10 and a 6. What should I do there? Cross cancel. What are 10 and 6 both divisible by, clearly? Becoming 5/3. So do it here, please. Take a look. Please do it here. See what I'm doing? Cross cancel first whenever possible. Because if you multiply it out, then you're just going to have to cancel in the end anyway. Whenever you can reduce early, do it. Always do it. Yes? You think you can? Why not?
It's not a factor.
Good. Up here it's a factor, right? This, take a look up, please. This is negative 1 times x. So this is a factor. X is a factor. And for a minute, moral, if there was no 7, then x is a factor. 2 times x, those are factors. But because we're subtracting 7, now 2x is an addend. And 7 is an addend. That cannot cancel with a factor up here. So my final answer will be negative 5x over 3 times the quantity 2x minus 7. Okay. Do I have to distribute the 3? No. Could I? Sure. Do I care? No. It makes no difference. It's like telling me your answer is 5 or 10 over 2. Okay, it makes no difference really. Question so far? That's method number 1, right? That's only method number 1. So let's jot this down real quick. Method number 1 is really using multiplication by the reciprocal. You got to do that. The next method will not use it. Again, method number 1 uses multiplication by the reciprocal. You have to do that. Okay, and it also involves separate common denominators for the top and bottom. That's going to be a distinguishing characteristic between this and the second method. It also involves a separate common denominator. Look here, please. 6 and 10, separate. Separate common denominators for the major top and the major bottom here. In the second method, we are now going to approach this that allows us to find the least common denominator for all of the minor fractions involved. So I'm going to replicate this slide real quick. Running out of room there. I'm going to rewrite the original. And look at all of the denominators for method number 2. Amongst all the denominators listed, whoops, that's not right. Or is that right? Yeah, that is right. Amongst all the denominators listed, what is the common denominator? Amongst all denominators. And if I don't know how to do it, what should I do with all my denominators? What do you start by doing with all your denominators? Yeah, factor them first. So if I'm not sure what's going on here, for the sake of this demonstration, I'm going to do that. X over 3 times 2 minus x over 3 all over x over 5 minus 7 over 5 minus 2. So again, ask yourself the question, what is common or what is in all of these denominators that we need? There's a 2 in 2 of the denominators, right? So we need a 2 somewhere. There's also a 3 in 2 of the denominators. There's also a 5 in 2 of the denominators. 3 times 2 is 6. 6 times 5 is 30. Isn't 30 common amongst all of these? Take a look. Isn't 30 common amongst all of these? Because what I just did is I said, what's common amongst all of these? Well, 3 is amongst 2 of them. 2 is amongst 2 of them. 5 is amongst 2 of them. So I need at least a 3, a 2, and a 5 in all of them. So 30 is my LCD. So what I could do, don't do it, please don't do it. What I could do is make this a 30 by multiplying by 5 over 5. Make this a 30 by multiplying by 10 over 10. And go through the process each time. Or this is what I like to do instead. This is the whole idea of method 2. Take the LCD that you have identified. Take the LCD and multiply, ready, watch this. Multiply the top and bottom by this LCD. The entire thing. And watch what happens. You have to then distribute. Right? Take a look what I'm doing. So this is still my same fraction. I could have done it up here if I wanted to. Distribute the 30 to both of your numerators and reduce whenever you can. Distributing this 30 here and here. Distributing this 30 here and here. Again, because these 30s are really over 1. Both of these 30s are over 1. So if you're not seeing what I'm doing, look. 30 up top goes to both of those. The 1 on the bottom goes to both of those. That doesn't do anything, a 1. But now what I've recognized, I'm going to scroll down so you can see this a little bit better. What I've recognized is this. Take a look where I'm pointing, please. This is going to be a 30 up here. There's a 30 up here and a 6. 30 over 6 is just 5, right? So this turns into just 5x. The next part here, take a look again. This 30 is going to go up top. This is going to be 30 over 3. 30 over 3 is just 10. So this is going to be a 10x. Then I go to the bottom and I do the same thing. I take the 30, multiply it over here. 30 over 5 is just 6. This becomes a 6x. And last but not least, 30 up top. Do not multiply by 7, because that makes it bigger and then you got to reduce it later anyway. Put the 30 up here. 30 over this 10 is what? 3. That leaves you with a 3 times 7, which makes this simply 21. I'm doing a lot of that work in my head, but you guys are a smart enough group that you need to be able to recognize what's happening. So physically, just put a 30 right here. 30 over 10 is 3. 3 times 7 is 21. Put the 30 right here. 30 over 5 is 6. 6 times x is 6x. You don't need to actually do a common denominator of the whole thing. Once you get the LCD, just multiply it out, and life is easy. Look how much easier this is, isn't it? What's the final answer? Negative 5x over 6x minus 21. It's the same thing we got the last time we got this. Negative 5x over 3 times 2x minus 7. It's the exact same thing. This is what we got using method A, and we left it factored. This is what we got using method B. It's the same exact thing. Distribute the 3. You get the same answer. So it's up to you at this point to choose method 1 or method 2. Yes? We don't have much time, so I want to make sure you understand that it's your choice, right? Method 1 or method 2. I want to maybe skip the second one. Let me look. No, I kind of want to go into the second one. Sorry, I don't want to skip the second one. Let's do it. So let's go to the problem here. Now, pause for a second and ask yourself the question. Can any of my denominators be factored further? Start with that question. Any of them? I hope not, right? It doesn't look. I got x plus 5, x plus 5, x minus 3. What is in the denominators that is missing in another denominator if I wanted an LCD for the whole thing? What would be my least common denominator for the entire thing that I would need?
Well, in the x minus 3, you would need multiplied by 5.
X plus 5, you mean?
Yeah.
Okay.
Yeah. And then for the other two, it would be x minus 3.
So are we all on the same page so far? But I don't want to do this. I'm just going to put it for now. You don't have to do this. So that's what would make this look right. So as a result, I can say on the side that my LCD for the entire thing is x plus 5, x minus 3. That's what my LCD is. Now, if you want to at this point, you can make an upper fraction or lower fraction and multiply by the reciprocal. You can do all that work, that's fine. But because I've identified that as my LCD for the whole thing, instead I'm going to do this. I'm going to erase these. And I'm going to go ahead, I think this is just faster. Again, I didn't learn this in high school. I never did it this way. I'm going to go ahead and multiply by x plus 5, x minus 3 up top, and x plus 5, x minus 3 down below. Now this is where bookkeeping comes into play. So if you're a little confused on this, just watch what I'm doing where I'm pointing. So this whole thing just goes up top here. And this is all over 1. So I'm not going to do this every time, but I'll do it for today. This is over 1, and this is over 1, really. Get used to those being over 1. So what does that create in the numerator? It creates x plus 5, x minus 3, times 3, all over, x plus 5. That's my numerator, really. But what can I reduce? That's what my overall numerator becomes. This is method number 2 I'm using here. I'm using method number 2. My overall numerator, this is it. So what do I do with these guys? These cancel. And that's always going to work out. That's why method 2 is nice. You don't have to worry about a separate denominator again. Cancel those. Now, in the denominator of this, what do I have to remember? What is key for this overall denominator? One word. One word. What's that one word? One person, that's it? What is key about this denominator that I have to remember to do? If I don't do it, it won't be right. Look at the denominator. Again, all we did so far was the numerator to here. What do I have to do with this denominator here? One word. Only Moro knows it apparently. One word. What is it? You got it?
Distribute.
Distribute. You got to remember to distribute. It's very tempting not to distribute this. It really is. Because you see these things, you want to just start canceling, right? I bet a bunch of you started to cancel x minus 3 and canceled x plus 5. You can't do it until you distribute. So please distribute. When you distribute this, it becomes the following. X plus 5, x minus 3, all times 2, plus, this is going to be x plus 5, x minus, as you get better at this, you don't have to show the work. I'm showing it for today. All over what we had to start for each denominator. So take a look at where I'm at if you need help. I've distributed to the denominator. Now I can cancel x minus 3 here and x plus 5 here. Again, why can I cancel? Because we have all factors here. We have all factors here. We have all factors here. That's why we can cancel those spots. This makes life so much easier because now all of my denominators are gone. They're all gone. Which leaves me behind with the following statement. Which leaves me behind with the following statement. X minus 3 up top times the 3. In the bottom, I've got 2 times x plus 5 plus 1 times x minus 3. I can distribute everything and collect terms and keep going. And I'll get a final answer of, in the numerator, still 3 times x minus 3. And the denominator, 3x plus 7. Okay, that's what my answer would come out to be. There are, listen carefully, examples 3, 4, 5. There are 3 more examples to do. You choose the method you want. In the video, I go over both methods for every one of them. Okay, I'll put the notes available for both sections, but you need to look at both of these sections tonight. Okay? If you really can't get the homework done tonight, I can give you an extra time for the homework. But if you can, try to get the homework done also. Okay, but definitely finish watching this video absolutely 100% tonight. Start the homework at least. I think I don't think the quiz is tomorrow. I think I'm going to give you a quiz later in the week. Yeah. I try not to give it the day after the lesson. So it will not be tomorrow. If anything, it'll be later in the week. I think it's on Moodle already. I put the date, I think.